Okay, let's do more examples for section 8.3. Some student ask the problem from 11 to 34. So I'm going to pick up some examples and try to solve it and see. One we add to 2k pi, one we add pi, k pi stuff. So there's a thing. So first of all, from 11 to 34, the requirement says solve each equations on the interval 0 to pi. So our theta is between 0 and 2 pi. So let's try it. For example, let's talk about the 16. 16 is a 4 cosine theta square minus 3 is equal to 0. Okay, let's solve it. So the cosine theta square is equal to 3 over 4. You move 3 to the right side and divide the equation by 4. And when you take square root, you have two solutions. Cosine theta is a sorry. Cosine theta is a square root of 3 over 2, or cosine theta is negative square root of 3 over 2. Over this whole cycle, it can be positive and negative. When cosine theta is a square root of 3 over 2, then theta is what? And theta is, what's this? It's a pi over 6, or negative pi over 6. But negative pi over 6, okay, let's first do this. Pi over 6, negative pi over 6, because it's even. And if cosine theta is a negative square root of 3 over 2, then theta is what? It's a 5 pi over 6 and a negative 5 pi over 6. Because it's symmetric, so you get one positive, you get the other one negative. This only works for cosine. Be careful, this trick only works for cosine. But this number, it is not in the domain 0 pi over 2. Sorry, in domain 0 pi, 2 pi, 0, 2 pi. So how do you do that? You add 2 pi. You add 2 pi, you make it in the range 0 to pi. Here you also add 2 pi. Because sine and the cosine, they have a period 2 pi, so you can only either add or subtract 2 pi. You cannot add pi or minus pi. You cannot subtract or add pi, 2 pi. So what we get? We get theta is a pi over 6. This is a 11 pi over 6, 5 pi over 6, and 7 pi over 6. Okay, so there are several numbers. This solution comes from the requirement that theta is between 0 and 2 pi. If there's no requirement, if there's no such condition, then you're going to just put theta pi over 6 plus 2k pi, or negative pi over 6 plus 2k pi, or here 5 pi over 6 plus 2k pi, or negative 5 pi over 6 plus 2k pi. Okay? So when there's no conditions, you always do such stuff. When there is a condition, you have to choose a proper case so that the solutions are in this domain. All right? Let's check 22. Cotangent of 2 theta over 3 is negative square root of 3. So first, you use x. You use substitution. You let x be 2 theta over 3. X is 2 theta over 3. Then you just check cotangent of x is negative square root of 3. Cotangent of x is negative square root of 3. So x is what? X is a radial table. X could be, it's in the second quadrant. Square root of 3 is a pi over cotangent pi over 6 is 5 pi over 6. It is 5 pi over 6. Well, let's check. I'm not so clear right now. So cotangent of x is cosine of x over sine of x. 5 pi over 6, cosine 5 pi over 6, it's negative. It's a square root of 3 over 2. Sine 5 pi over 6 is positive 1/2. The ratio is negative square root of 3. It's right. Okay, so you have this angle. X is equal to that. Or here, x can also be 5 pi over 6 plus k pi. Be careful, this place you need to add k pi. This is a special point. Once you get one special point, you add k pi to get all solutions. Represents all solutions. I don't say all solutions with satisfying the condition, but I just say it represents all solutions for this equation. For the equation. Now let's back to theta. So what is a theta? X is this, so it means 2 theta over 3 is equal to 5 pi over 6 plus k pi. You divide the equation by 2 over 3, you get the theta is, so 5 pi over 6 plus 2k pi times 3/2. It becomes 5 pi over 4 plus 5 pi over 4 plus 3/2 k pi. Let's check one by one. If k is 0, then theta is what? Theta is 5 pi over 4. It's inside the range. It's inside this 0 to pi. If k is a 1, theta is 5 pi over 4 plus 3 pi over 2. 5 pi over 4 plus 3 pi over 2. This value is greater than 2 pi, so no. And if k is negative 1, then we have what? We have theta is 5 pi over 4 minus 3 pi over 2. 5 pi over 4 is 1.25 pi. 3 pi over 2 is 1.5 pi. The subtraction is less than 0. It's also not inside. No. So there's only one solution. Okay? So that's the computation. You have to try them. And this place we didn't try a lot because you plus 2k pi. Once you add 2k pi, you will exceed this 2 pi. So that's why we didn't try it. But here we tried since cotangent, it has a period pi. The domain has 2 cycles. It's from 0 to 2 pi. So possibly it contains 2 cycles. I just say possibly. So I have to check if it really contains 2 cycles. But by this verification, I know 0 is in it. And its right neighbor, its left neighbor are both not in this cycle. So there's no the second answer. All right? Okay. So that's why I have to try several things. And this one I don't try it because this is just one cycle. You figure out the solution in one cycle, that's enough. When I say one cycle means 0 to pi, the period of sine, cosine, cosecant, secant, they all have period 2 pi. But the tangent, cotangent have period pi. Okay, let's see another one. 31. Cosine 2 theta minus pi over 2 is equal to -1. Okay, so let x be 2 theta minus pi over 2. Then you solve cosine x is equal to -1. we know that there's only one value. Then x is going to be pi plus 2k pi. Only cosine pi is -1 in one cycle, and then you add 2k pi. So this represents all solutions satisfying this equation. So x is a 2 theta minus pi over 2. So 2 theta minus pi over 2 is equal to pi plus 2k pi. You solve for theta. So move pi over 2 to the right side. It's a 3 pi over 2 plus 2k pi. And divided by 2, you get a pi over 4 plus k pi. Okay? So let's try. Let's try. Because here you see k is 0. Theta is a 3 pi over 4. Good. K is 1. Theta is a 3 pi over 4 plus pi, 7 pi over 4. It's still good. It's less than 2 pi. And k is equal to 2. Theta is 3 pi over 4 plus 2 pi. It's bigger. It's bad. And k is equal to -1. Theta is a 3 pi over 4 and minus pi is negative pi over 4. It's bad. So you have two solutions. You have two solutions. So from these two questions, or from these two problems, we can see that first, you just use x to replace these very fancy expressions and figure out the solution set, the complete solution set for x, and then you solve for theta. After you get the theta, you are going to choose the proper k, integer k, so that you figure out all possible solutions. Okay? Let's try the 34. Cosine of theta over 3 minus pi over 4 is equal to 1/2. So let x be theta over 3 minus pi over 4. Then cosine x is 1/2. How many solutions? 60 degrees and -60 degrees. So x can be pi over 3 plus 2k pi, or x can be negative pi over 3 plus 2k pi. Okay? Cosine pi over 3 is 1/2. Okay, for the first one, x is a theta over 3 minus pi over 4 is equal to pi over 3 plus 2k pi. You solve it, it's theta over 3 is pi over 3 plus pi over 4 is a 7 pi over 12 plus 2k pi. You multiply it by 3, you get the theta is 7 pi over 4 plus 6k pi. You can see that when k is 0, it's inside the 0 to pi. When k is greater than 1 or less than 1, they are not inside. So k equal to 0, theta is 7 pi over 4. It's good. Other answers are not good. Okay? K equal to 1, k equal to -1, they are bad. And for the other one, theta over 3 minus pi over 4 is negative pi over 3 plus 2k pi. Okay? Theta over 3 is pi over 4 minus pi over 3 plus 2k pi. So it is negative pi over 12 plus 2k pi. So theta is negative pi over 4 plus 6k pi. Okay, you just multiply the two sides by 3, you get 6. Negative pi over 4 plus 6k pi. And when k is 0, it's negative. Theta is negative pi over 4, it's bad. When k is 1, k is -1, they're all bad. So from this direction, there's no solution. So there's only one solution. Okay? So I hope you can understand the steps for the solution of those equations if you have the requirement theta between 0 and 2 pi. Okay?